We're going to look at how we solve 3x3 simultaneous equations in this video. Now, whenever you're solving a 3x3 simultaneous equations, the idea is you want to eliminate two variables so that you're left with one, then you can use that to substitute it all back into the originals. Now, if you start doing it and you get a little bit lost, there isn't a way that you can do it so that you can always easily eliminate it. You eliminate this triangle so that you're left with three different equations. Now, once you've eliminated that triangle, you might notice this just has z. Once you've found z, you can then find y, then you can find x. This is why this works. If you ever get told what it's called Gaussian elimination. Anyway, so we want to eliminate this triangle. We have an x here. We have a 2x there and a 5x there. So we need to eliminate that. So to do that, actually, it might even be easy if we rearrange it first. Now, it doesn't matter which variable you have first. Rather than having the x's first, you can always have the y's first. The reason why I'm saying that is because I noticed that there are two y's here that we can just easily eliminate. Okay, so 1, 2, 3. If we do the third equation minus the second equation, we're then left with 3x plus z equals to -2. I'll call this equation 4. Then we also need to be left with another equation where we have just an x and a z. Pick any equation you like to eliminate. Let's say we do first one minus 4 times the second one. So then we have 3x minus 4y plus 5z equals to 10. 4 times the second equation gives us 8x plus 4y, whoops, that should be a plus, minus 12z equals to -28. And we're adding them. So then by doing that, the y's cancel and we're left with x's. So we have 11x minus 7z equals to -18. We'll call that equation 5. Now if I write all of these equations, and if it rubs out, that'd be great. If I write all of these equations out in a line, we have 3x minus 4y plus 5z equals to 10. That was our first equation. We have 3x plus z equals to -2. Our fourth equation. Then we have our fifth equation, 11x minus 7z equals to -18. So remember the triangle we were eliminating? We've eliminated two of the triangles, two parts of it, but we need to eliminate this x here. Now again, you can pick whichever variable. You might even notice that the z can be eliminated. So let's just eliminate the z. So if we do 7 times the fourth equation plus the fifth one, that will eliminate it. So 7 times the fourth equation gives us 21x plus 7z equals to -14. Then the other one is 11x minus 7z equals to -18. We're going to add these two. So then we're left with 32x equals to -32. Again, we'll write all three equations out. 3x minus 4y plus 5z equals to 10. 3x plus z equals to -2. Then we have the 32x equals to -32. Now that we've done that, you might notice the triangle is now empty. That means we can solve it. So Once we find x, we can then find z, then we can find y. So using the fifth equation, x is equal to -1. Plug this into the fourth equation. We have 3 times -1 plus z equals to -2. That means z is equal to 1. Putting this back in the original, you have 3 times -1 minus 4y plus 5 equals to 10. So then that's -4y plus 2 equals to 10. So that's an 8. So y is equal to -2. So then x is equal to -1, y equals to -2, and z equals to 1. Now just remember, I said eliminate the triangle. This keeps moving as we go if you had a look. So this shifted to the right. Then on the very last one, that one shifted to the right. So that's where the triangle comes from. Alternatively, if you want to, you can rearrange everything first so you know which ones you're eliminating. Then as you eliminate the triangles, the x, y's, and z's will be in the right positions. One last thing, you might notice I keep putting in equations as we go. This first one, I rearranged it so that we had 4 and 5. You can actually put in any equations that you find, but you want to always put down any equations that you've eliminated a variable for. So what that means is instead of putting down number 4 here, oops, it should be 6, I just noticed. Instead of putting down number 4 there, I could have put down number 5, and that would have worked out to be the same. So I could have put down this one, and that will still give me the same answer. Just remember, the idea is we want to find it so that we're left with one variable, then we go back and substitute it back through.